When we talk about graphing equations and standard equations, the first thing a lot of people think of is the slope equation, y equals mx plus b. It's a very standard equation, and basically everybody sees it from middle school on. One of the most basic shapes we work with is a circle, but we really never talk about the standard equation of a circle. It's actually quite simple. Two things you need to know would be where your center of the circle is, and then the other thing you need to know is your radius. As long as you know those two things, it's pretty simple. Our equation is x minus h squared plus y minus k squared, sorry, that's a minus there, y minus k squared, and the whole thing is going to equal my radius squared. So you can really see exactly where these different parts of the equation apply. Now if I look at the graphic provided here, we can see I have a circle. Obviously, my radius is, again, my distance from the center point to the outside. And then my center point, I want to label that as positive h, positive k. That's going to be really important because in the equation, you can see that I have a minus h and a minus k. Really doesn't make a difference when we're talking in the first quadrant, but once we start to get into some quadrants where we're going to have negative numbers, it just switches the values on us and it changes the values. So for our first quadrant, you're going to see it's always going to be minus h and k. For our third quadrant, where both of my coordinates would be a negative, it's actually going to give me a plus h and a plus k. So really when you're talking about your coordinates, you're going to talk about the opposite operation for your coordinates. And that'll make more sense in a second. So if we dive into some of these problems, and we dive into a couple of these problems. Start off with two pretty easy ones. I want to write the equation of a circle, the circle A that is centered at the origin with a radius of 6. Now if we want to draw it out, we could say it's centered at the origin, and our radius out here is 6. So that goes to 6, positive 6, negative 6, negative 6. Now remember, all we need to know is my center point and my radius, which I do know. So I could look at these and I can solve that. So, my center point is the origin is going to be 0, 0. My radius is a 6. If I plug these in, I'll have x minus 0, which I won't even write, so I'll have x squared plus y minus 0, which is going to be y squared, is going to be equal to my radius squared, which is going to be 36. Boom. Simple enough. That's my equation of a circle. If I look at circle D now, it's got it passes through 1, negative 2, and the center is at 3, 3. If we draw a quick little picture up here, so our center is at 3, 3. We can put a dot up there. And it passes through 1, negative 2, which is going to be down here somewhere. So we're going to see the circle is going to go off the page a little bit, come back around. It's going to look something like that. But remember, all we need to know is I've got my center points, and then I have a point at which it passes through. So I can use that point to find what my radius is going to be there. So let's plug in our radius, or what we know about our center points first. We know it's at 3, 3, so I can say the beginning part of my equation is going to be x minus 3 squared, y minus 3 squared. The whole thing is going to be equal to my radius squared. Now, I can do one of two things. I can use the distance formula, and I can find what the distance is between these 2 points, and that'll tell me what my radius is. Or, since I know that this point is on that circle, I can plug 1 in for x, and I can plug negative 2 in for y, and I can solve it, and that'll tell me exactly what my radius squared is equal to. So I'm going to do it that way. I'm going to plug in 1 for x, and I'm going to plug in negative 2 for y, I'm just going to set these equal to my radius squared. 1 minus 3 is negative 2. So I'll have negative 2 squared. Plus negative 2 minus 3 is negative 5. So I'll have a negative 5 squared. That should equal my radius squared. So I've got a 4 plus 25 equals my radius squared. So my radius squared is equal to 29. So now if I go back up to my original equation, I had my h, I had my k. The only thing I was missing here was my radius squared. If I just solved for my radius squared and I know it's equal to 29, then all I'm going to do is go back up here. I'm going to put in my 29, and I'm going to say that right there is the equation that I'm looking for. So that equation there can represent my circle. Perfect. And we'll do one more. We're just going to graph this one. So I have my center point. Remember, I have x minus h is my general equation squared plus y minus k is my general equation squared, and that whole thing equals my radius squared. So if I look up here where I see that plus 2, I've got to actually say, well, I have x minus negative 2. That's where that plus 2 comes from. So my negative 2, like I said, we've got to switch the signs there. My negative 2 is my h. So h is negative 2. My k, since it's minus, I can say it's going to be positive 1. So if you look in here, the easiest way to think about it is whatever you see in here, it's going to be the opposite. So x is negative 2, y is positive 1. Then my radius is going to be the square root of 4, which equals 2. So if I jump up here, I can graph that. Negative 2, positive 1 is going to be this point here. My radius is a positive 2. So I'm going to put more points in for my positive 2. And the rest is my circle. Boom. So that's all I got to do for my circle. I've got to know, oops, I took that down too far. Rookie mistake. So it should be up here. I was wondering why it looked a little elongated. There we go. That's what my circle is going to look like. All I need to know is my center points and my radius. And I can write the equations and I can graph.